Okay, so we're going to go over the Unit 2 review here, graphing linear equations. I just wanted to throw up all of the different learning goals that we're going to go through. All of these things are going to be things on your test on Monday. So first of all, remember that you have to understand how to plot points and lines in the coordinate plane. So obviously being able to plot one point or several points in order to construct a line, and then also being able to determine if an equation is in fact linear. So we'll review those things. The second one, we want to understand how to graph a linear equation in one variable. So if we only have one variable that we're working with, my lines are either going to be horizontal or vertical, and you have to know how to tell the difference. And then we also want to be able to determine if a specific point is on a particular horizontal or vertical line. Okay? The third thing that we focused on in this unit was actually graphing linear equations in two variables, right? So two variables instead of one, and we did this 4 different ways. Constructing a table, using a graphing calculator. We did it by finding the x and y intercepts when it was in standard form. And then probably the one that we're going to use the most is graphing our lines in slope-intercept form. And then our fourth learning goal was understanding what slope represents. So first of all, of course, we need to be able to calculate the slope using 2 points that are on a line. So if I give you a graph, find the 2 points and calculate the slope. We also talked about calculating the slope using the graph, and we talked about calculating the slope using a formula. So depending on how the information is presented to you, how are you going to determine which method you're going to use to calculate the slope? And then, of course, describing what slope represents in a particular situation. We didn't get to our fifth learning goal in this particular unit, so we'll pick that back up in the next unit, and we're going to really focus on modeling behavior with linear equations. So really coming up with equations that represent different phenomena that we see going on. Okay, so let's begin. The first thing we want to review is how to plot points. So remember, the keys here are remembering that this is the x-axis going horizontally, this is the y-axis going vertically, this is the positive direction, the negative direction, positive y, negative y. So if we wanted to plot the point 5, 4, all of these points are in the form x, y, so the x coordinate comes first. So we move 1, 2, 3, 4, 5 in the x direction, and we move up 1, 2, 3, 4 in the y direction, and that would be our coordinate. Excuse me. So this coordinate here would be 5, 4. All right, if we look at the next one, we have negative 3, 2, so we're moving negative 3 in the x direction, so that's back 1, 2, 3. And we're moving 2 in the y direction, that's positive 2, so that's up 2. And so those points would meet right here, and that would be the point negative 3, 2. Third, we want to graph the point 2, 0. Now when we have a 0 here, that just means we're not moving up or down at all. So we move 2 in the x direction. We don't move up or down, and so that point is actually on the x-axis. So that would be 2, 0. And then finally we have 0, negative 4. So again, we're not moving any in the x direction. We're only moving in the y direction, and we're moving down. So 0, negative 4 would be down 1, 2, 3, 4. And there we have the point. Remember as well, we also had names for each of our quadrants. The positive area, where both x and y are positive, is quadrant 1. The negative positive area is quadrant 2. Negative negative is quadrant 3, and positive negative is quadrant 4. So they move in a counterclockwise rotation starting from the positive region. Now that's important because I want you to be able to tell me what quadrant a point is in. So if we look at each of these points here, let's look at each of the points that we see listed. 5, 4 is in quadrant 1. Negative 3, 2 is in quadrant 2. 2, 0 is not in a quadrant, so we say it's on the x-axis. And 0, negative 4 is not in a quadrant either. We say it's on the y-axis. So it doesn't have to be in a quadrant. If it's on one of the axes, that's what you would state there. Okay? And I want you to also be able to go backwards and be able to tell me the coordinate of a point that's given to you. So if we look at these points that we see here, this point right up here has been moved to the right 2, so that's 2 in the x direction, and it's moved up 1, 2, 3, 4 up, so that's 4 in the y direction, so this point is 2, 4. If we look at this point right here, we haven't moved left or right any, so the x coordinate is 0, and we move down 1, so the y coordinate is negative 1. And for this point right here, we've moved left, and we've moved left 2, so that's negative 2 in the x direction, but we haven't moved up or down any, so that's the coordinate negative 2, 0. Alright, so let's talk about finding slope. One of the ways I want you to be able to do it is from a graph. So let's say I gave you this line right here. I'm going to try to make it so that it has some nice intersection points here, but I'm not sure how good I did. Let's try this, fix this again here. Get that there, get that here, and in the practice it actually shows you 2 nice coordinates, but it may not always show you 2 nice coordinates. You might have to really look carefully for where it crosses nice points. So let's say we knew that this point was on the graph, this point was on the graph, and this point was on the graph. Remember, to find slope from a graph, probably the easiest way to do it is to use the idea of rise over run. Remember, the rise, if it goes up, is positive, and if it goes down, is negative. But the run, we always want to go from left to right. If we always go from left to right with the run, then the up and down is going to take care of the positive and negative aspect of the slope for us. So, if I look at any 2 points here, maybe this point and this point, and I draw a little triangle, you can see I've gone up 3 spaces, and I went up, so that's a rise, and then going to the right 1. My slope in this case would be a rise of 3 and a run of 1, 3 over 1, or we could just say that the slope is 3. Okay, so pay attention to whether or not it's positive or negative. If you had a line going like this, I'll make this one a real easy one here. Is this positive slope or negative slope? You can tell just by looking at it, it's negative slope. If you found 2 points on the line, maybe you found these 2 points on the line, then you would see that the rise from left to right is down 2, and the run is over 2, and then we want to reduce that if we can. Negative 2 divided by 2 is negative 1, so that slope is actually negative 1. Alright, I also want you to be able to find the slope using the slope formula for 2 points. The first thing that I would recommend doing is labeling your points x1, y1 and x2, y2, and then plugging them into the formula. So we can see y2 is 3. We're going to subtract y1, which is 4. We're going to divide that by x2, which is negative 2, minus x1, which is 5. 3 minus 4 is negative 1. Negative 2 minus 5 is negative 7. But we should simplify this because we have a negative divided by a negative, which is, of course, positive. So in this case, our slope is positive 1/7. We could also just do a quick sketch. 5, 4 is like over 5 up 4. That's here. Negative 2, 3 is about right here. And you can see pretty clearly that if you connected these, the slope would be positive. So that's a great check. A third way I want you to be able to identify slope is if I give you an equation. So most of these equations are in slope-intercept form, y equals mx plus b, where m, of course, still represents the slope. So what I'm multiplying x by is the slope. So if we look at this first example, y equals negative 2x plus 1, the slope is negative 2, but of course we might think about that as negative 2 over 1, so we have the rise over the run. In the second example, x is getting multiplied by 3/2, so my slope is 3/2, a rise of 3, a run of 2. Now the third and fourth examples are a little bit different. We have y equals 2 and x equals 1. So let's think about what these lines look like. Y equals 2 crosses the y-axis at 2, and since it has to cross the y-axis, remember that means that it's a horizontal line where all of the y-coordinates along that line are exactly 2. Horizontal lines have 0 slope. So even though we don't have an equation written in slope-intercept form here, we could write this as 0x plus 2, so the slope is 0. In the fourth example, we have x equals negative 1, and if I just drew a quick sketch of that, we know it has to cross the x-axis at negative 1. That means that the line has to be vertical in order to cross the x-axis. All my x-coordinates are negative 1. We can't really write this equation in slope-intercept form because there is no y. And in this case, when we have a vertical line, we say that the slope doesn't exist. There is no slope, or the slope is undefined. Those are the two ways that we kind of describe vertical lines and their slope. Alright, so the next thing we talked about was graphing equations, and we did this 4 different ways. The first way was using a table. I am going to ask you to use a table on the test and fill it out like we're going to do here. So let's graph this equation using a table of values. We're going to graph y equals negative 4x plus 3. So I've chosen the x values for you, but you could choose any x values you wanted to. I like to choose ones that are centered around x equals 0, because that's going to be centered around the y-axis, which is often helpful. So remember what we do is we're plugging in that value for x into this expression. So we would have y equals negative 4 times negative 2 plus 3. Negative 4 times negative 2 is 8. 8 plus 3 is 11. If I plug in negative 1, I get y equals negative 4 times negative 1 plus 3. Negative 4 times negative 1 is positive 4, and 4 plus 3 is 7. Plugging in 0, we have negative 4 times 0 plus 3. Negative 4 times 0 is 0. 0 plus 3 is 3. And then if I plug in 1, now we have negative 4 times 1 plus 3. So negative 4 times 1 is negative 4. And then when I add 3, negative 4 plus 3 is negative 1. And one more to do here. If I plug in 2, I have negative 4 times 2 plus 3. Negative 4 times 2 is negative 8. And negative 8 plus 3 is negative 5. Now in this particular graph, I can't fit all 5 of these points, but I can fit these 3. So those are the ones I'm going to focus on. If x is 0, y is 3. So that's the coordinate 0, 3. That point's going to be on my graph. So going 0 in the x direction and up 3 in the y direction, we plot that point. Then we see when x is 1, y is negative 1. So that's the next point. Oops, not negative here. X is positive 1. Y is negative 1. So that's over 1, down 1. So that point is right there. And then finally, 2, negative 5 is the third coordinate I can fit on my graph. If x is 2, y is negative 5. And we can see that in fact these lines, or these points, all lie in a nice straight line. They are linear because they all lie on a particular line. Okay, so that's one way we talked about graphing. Another thing we talked about was graphing horizontal and vertical lines. We did this a little bit in the previous page, but remember if we have y equals 2, this line is going to cross the y-axis. So we find 2 on the y-axis. So go up to 2 right there. And if it's going to cross that axis, that means my line must look like this. So this is the equation y equals 2. And you can notice that every point on that line has a y value of 2. When I want to graph x equals -3, of course this one needs to cross the x-axis. So we find -3 on the x-axis, and we can see in order for it to cross, that has to be a vertical line, and every single place on that line has an x-coordinate of -3. So anytime you have x equals a number, the line will be vertical. Anytime you have y equals a number, the line will be horizontal. We had 2 more ways of graphing lines. The next one I'm going to talk about is by finding the intercepts. Remember, intercept is where it crosses an axis. So the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. And to find that, we either are going to plug in x equals 0 or y equals 0. If I plug in x equals 0, this actually gives me the y-intercept, because that's going to give me a place where it crosses along here, because I haven't moved left or right any in the x direction. And if I plug in y equals 0, that actually gives me the x-intercept, where it crosses the x-axis. So if we have the equation 2x minus 3y equals -6, let's find the intercepts. So first let's plug in x equals 0. That's going to give me 2 times 0 minus 3y equals -6. But of course 2 times 0 is nothing. It's as if that term goes away. That's 0. And 0 minus 3y is -3y. If -3y equals -6, we can divide both sides by -3. A negative divided by a negative is positive, so we can see that y equals 2. Another way of saying that is that the point 0, 2 is on the graph. X was 0, and when x was 0, y was 2. So that's right there. So now we're going to plug in y equals 0 to find the x-intercept. So this time we have 2x minus 3 times 0 equals -6. The 3 times 0 is 0, so that leaves me with 2x equals -6. And dividing by 2 gives me x equals -3. So using those two things, that means the point -3, 0 is on our graph. So those are my 2 points. Then I get out my ruler so I can draw a nice straight line all the way through the graph. And then the fourth way we talked about graphing was using slope-intercept form. In other words, y equals mx plus b. So you have to remember that m represents the slope. That's what you're multiplying x by. B represents the y-intercept, where it crosses the y-axis. So let's just do one example here. This is what we've been working on most recently, so hopefully this is fresh in our memories. We can see that the slope in this case is -3/2. That's what I'm multiplying x by. That tells me I'm going to go down 3 and to the right 2 when using my slope. I can see that the y-intercept is -2 because I'm subtracting 2 here. And remember, what we do is we plot the y-intercept first, and then we use the slope to graph more points, and then we connect the dots. So my y-intercept is -2. That's down here. My slope is -3/2, so down 3 over 2. So from here, I'm going to go down 1, 2, 3, and over 2. And I can't fit any more points in keeping in that direction, so I reverse it. Down 3 over 2, if I reverse both of those, that's like saying up 3 and to the left 2, and that's going to give me the same slope. So up 1, 2, 3, left 2, up 1, 2, 3, left 2, and again, we'll connect our points in a nice straight line. And there we have it. The last thing I want you guys to focus on is converting your equations into slope-intercept form. This is a huge skill that we're going to come back to over and over and over again. And the main idea here is we want to get y by itself. If we want to make it look like y equals mx plus b, y has to be all by itself, and we want it to equal something times x plus something else. So getting y alone is kind of the main idea here. So let's look at these two examples. Here we have 2x minus 4y plus 8 equals 0. There's two things that are in the way of y. The first is maybe my x term. So I can't just, move it. I have to do math with it. So I have to undo it. Since this is positive 2x, I subtract 2x from both sides. That gives me 0 here. So now we have negative 4y plus 8 equals negative 2x. But now I still have to deal with this 8. So since it's positive 8, I'm going to subtract 8 from both sides. And please realize that when you do this, I cannot combine negative 2x and negative 8. Negative 2x is a variable term. It has an x. Negative 8 is a constant term. It has no variable. They're not like terms. We cannot combine them. So all we can do is just write this as negative 2x minus 8. Now finally we have to undo this multiplication. So we're going to divide everything by negative 4. And a lot of times it's easier to just write it out where you're showing you're dividing every single term by negative 4. So negative 4 divided by negative 4 is 1. That leaves me with 1y. Here we have negative 2 divided by negative 4. Well, we know a negative divided by a negative is a positive, and we're just going to reduce that fraction. 2/4 reduces to 1/2 because we're not worried about fractions with slope-intercept form. They're great. They tell me the rise and the run. And then we simplify. Negative 8 divided by negative 4 is positive 2. Is my equation in slope-intercept form now? Does it look like something times x plus a number? It does, so we're good to go. Let's do the second example. 3x minus 5y equals 10. Again, we want to get y by itself, so we'll subtract 3x from both sides. Now since we already have a constant on the right, I would recommend that you, instead of writing this as 10 minus 3x, which is mathematically correct, instead we write this as negative 3x plus 10, because the 10 is positive. That's getting it into the mx plus b form that we want, something times x. We want the x term to be first. Now we'll divide everything by negative 5. Pay attention to your positive and negative signs here. Negative 5 divided by negative 5 is positive 1, but negative 3 divided by negative 5 is positive, and we'll just leave it as 3/5. Then positive 10 divided by negative 5, positive divided by negative is negative, and so that will be minus 2. And there's our equation in slope-intercept form that we were looking for. That's the last thing that I'm going to go over in the review here. So what I want you guys to do now is use those examples to help you through the practice problems that I gave you, and figure out if you have any questions at all. Go back and look through the examples in this video again and see if looking at those examples help you with the step-by-step approach to the problems that I gave you on your review packet. And that's it. I'll see you on Monday, and we'll have our last test until the final.